This is a demonstration of my SDI1980 Python game. It is modeled after a popular 1980s video game, so I'm going to run the program and show you what it does before we look at how it does it. So the program begins giving the player a message, and so I'm going to hit the A key to begin, and immediately the game starts, and a timer begins, and you have 60 seconds to get as many points as you can. And so the way the game is played is you move your cursor around the screen and click the cursor in order to zap and cause an explosion. And the explosions will create clouds that expand, and those expanding clouds will block the projectiles that are falling from the top of the screen. For every projectile you block, you get some points. If a projectile gets past you and hits the ground, you get points subtracted. And every time you zap, it costs you some energy, and that subtracts points from your score as well. So that prevents you from just spamming missiles. Your score will go down if you do this. Okay. And then when the timer runs out, you get a game over message and you see your final score. I'm going to begin by explaining there are two types of objects this program uses in order to play this game. So one class is called MissileTurtle, and it's called MissileTurtle because it's an object that is used to track the progress of a missile, and it inherits from Turtle. So essentially it's a turtle with some extra. I have a second class called ExplosionTurtle, which is a turtle subclass that uses turtles to create explosions. And so when I want to create a new explosion, I make one of these objects, and it inherits all the functionality of turtles, plus some additional functionality that lets me manage explosions. I'm going to talk a little bit about the setup of the program, and then I'm going to jump right into the game loop. So game data setup, I create two lists, one list that keeps track of explosions and one list that keeps track of missiles. And see that when I add an explosion, I'm going to add it to this list so that I can check back with it. Same thing with missiles. Then I have some constants that I need in order to keep track of points, like things I'm going to add to the score, for example. And that's most of what's going on here. Oh, I also set the tick interval, which is how long in milliseconds is between each update of the screen in this game. Okay. Then I create some global variables. I did not design this in a completely object-oriented way. If I had, then the game itself would be an object, or it would be used like an object, and then I wouldn't have needed these variables to be global. Later on in my game loop, I use the global keyword so that I can access these and update them. But if I were to rewrite this program, I would do it in a way so that those didn't need to be global. Okay, and that's keeping track of the score, the timer that's counting down, and then because the screen updates faster than a second, I'm keeping track of how many milliseconds within each second have accumulated so that I can keep track of the timer in any case. Then I create a reference to the screen so that I can use all the functions that the turtle screen provides. And then I immediately use that reference to turn off automatic updating of the turtles. This tracer function allows me to stop the turtle from updating the screen every time a turtle is changed, and that allows me to make a bunch of changes to turtles and then force an update, which makes my game run much more smoothly because it's not flickering and updating every time I move a turtle. Then I fiddle with the screen size, and I create some additional turtles that aren't explosions or missiles, and they're used to draw the border of the screen and to write the score and the timer. So those are going to be used later on. But I'm going to jump to the bottom, and I'm going to show you that the game is listening for the A key to be pressed, and that is what starts the game. So what happens when the A key is pressed? begin game is called. So let's look at begin game and see what that does. So begin game clears the message from the screen, draws the border, and then sets up the position of the score turtle, the turtle that draws the score. And then it turns on listening for clicks, which are going to be the zaps being fired by the player. And then it also turns on the game timer. This begins the game loop. This first event starts the game running by calling gametick. At least it calls gametick after the first tick interval passes. So let's go and see what happens when gametick is called. So gametick is going to be called every, I think it was 50 milliseconds. After the game interval passes, gametick is called. So let's say every 50 milliseconds. And this function has 3 phases to it. It checks collisions, it updates the state of the game, and then it updates the drawing. So let's see what it does in those phases. So this first phase is the collision check. Let's see how collisions are checked. We loop through all of the explosions that we have in the list, if any exist. And then we loop within that. For every explosion, we then loop through the list of missiles, and then we call check collision on the explosion to see if the missiles have collided with any explosions. If they have, if there has been a collision, then we prepare a new explosion because we are going to remove the missile and then we're going to replace that with an explosion. If there isn't a collision here, we just ignore the situation. So we go through the entire list of explosions, checking whether each missile has collided with it. And then we remove the missile from the list if it has collided with an explosion, and we clear it so that it disappears, and we also increment the score. So once collisions are handled, then we update the game state. Now, this updating of the game state is happening behind the scenes. You're not going to see any results of this game state updating until we decide to update the screen. So we can do a bunch of things here, and it doesn't slow the program down that much. So what do we do? So the first thing we do is for every explosion, we're going to check whether the explosion has reached its maximum size. And if it has reached its maximum size, then we are going to remove that explosion from the list of explosions and get rid of it from the screen. Okay, so that's what happens when an explosion kind of ages out of the game. Then we loop through all the missiles and we see if any of the missiles have reached the bottom of the screen. And if they have, we remove them from the missile list. And then we register that there has been a landed penalty in the score. So that's how we get rid of missiles that have not been blocked. Now we go through the list of explosions and we grow each explosion. So we're doing this in a separate for loop because we may have removed explosions. So we go through the list again and we grow the remaining explosions. I suppose we could have done that in the loop after we've removed things, but I decided to do it in a separate loop here. Then we go through the missiles and we advance the positions of the missiles. Then we go through the missiles again, and now we are going to generate a random number. And if that random number is below a certain number, then we are going to tell the missile to split into 2 missiles. So if you noticed when I ran the game, actually I can show you again. Sometimes missiles will split into multiple missiles. So there's one splitting right there. Okay, so that's a feature of the game that makes the game a little bit more interesting. So split is a routine that belongs to the missile class, and by calling that, we just have the missile go ahead and do that splitting. And we can look at that later. Okay, so next we generate a random number, and if that random number is below some number, we create a new missile at the top of the screen. So this is how missiles are created. After a certain amount of time passes, because of this, there's a slight chance of missiles being created, and we could adjust these parameters to make more missiles or fewer missiles appear, and that's essentially what I did. I played with these numbers until I liked how many missiles were being created. All right, so now, we have this temp explode list, which I didn't mention before. So if we go up, you'll notice that what I did was when I created the new explosions, I didn't right away add them to the list because I didn't want them to be to have their data updated yet. So what I did was I stored them in a temporary list. Once I've done all of the other updating, then I go back to the temporary list and I take the all the explosions that are in that temporary list and I add them to the official explosions list. so that they become part of the game now. Then I add the tick interval to the subsecond. Here I'm keeping track of how many milliseconds have gone by, and you can see immediately here why I'm keeping track of that. So if the milliseconds have gone over 1,000, that means a second has gone by, and I subtract 1 from the timer, and then I reset the sub-second count. So this is what is keeping track of time going by so that I can subtract time from the timer. So once all of that updating has completed, now it's time to draw the score on the screen, which includes the timer actually, and then force an update of the screen. And then once the screen update is forced, I check whether the timer is greater than 0. If it is greater than 0, that means the game is still going on, and then I register an update at the next tick interval to call gametick again. So this essentially, we go to sleep for 50 milliseconds, and we're going to get a message 50 milliseconds from now to wake up and update the game state again and check for collisions and do all that good stuff. If the timer is not greater than 0, then that means the game is over, and we call an endgame function. Okay, so the only one of these routines I'm going to look at more closely is the split routine, which belongs to MissileTurtle, and it's right there. And if you want to look more closely at any of my functions, there's going to be a link to a GitHub repository where this code is public. Okay, so here's the split routine, and what happens in the split routine is the first thing is we check if this missile was already split before. We only want to split missiles one time. It gets a little crazy if you keep splitting off the missiles, so I only allowed one split at a time. So it checks if this missile was split already. If it was not split, then we tell this missile, okay, now you've been split. We set split to true. We set was split to true. Then we create a random number of somewhere between 20 and 40 degrees, and that random number is going to be used to decide what direction to send the split missiles off in. So this is going to be a positive number, and so we send this missile off in the direction of whatever heading it was already on plus that heading modifier. And then once this missile is now going off in a different direction, we create a new missile completely out of thin air. We create a new missile and we set its position to our current position, and then we set its heading to what our heading is minus the head mod. Okay, and then that's it. I tell the warhead that it's been split too, so it shouldn't be split in the future, and then I add the warhead to the list of projectiles, of missiles. That's it. That's how this game works, and I hope you found some of this useful. Like I said, check out the code if you want to see how the functions work in depth, and leave a comment if you have any questions.